Hi, I'm Sean Gannon, and this is Minute Math. And we have another geometry problem here. We want to find the area of this inner square, okay, in our given figure. A few things that we know. Obviously, all the points that you see, we have that it's a square. E, F, G, H is a square again. The height of this triangle, we see, is 2. That's the length of CD. And as well as the bottom length here, AB is a 3. With just that information here, can we find the area of this inner square? So I want you to pause this video, see if you can determine what that answer is, and write it down in the comment section below, but don't peek, don't look at the other answers there first. Once you think that you can solve it, or got an answer, let's go watch this and see if my solution was the same as yours and how I tackled it, or hopefully you learned a new way to solve this type of problem. Okay. Well, the first thing I'm looking at here is my knowledge of a square. What do we know about lines EF and HG? EF is parallel to line HG. Definition of a square here. We got some right angles. We know the side lengths are congruent, but they're right angles here, meaning these two lines are parallel. How does that help us? AC is like a transversal through two parallel lines, meaning here that this angle CEF, let's call it angle alpha, is equal to this angle right here, EAH. They are congruent. We can do this similarly on the other side of the triangle. Again, parallel lines right here. We have BC, transversal, that's cutting it through. So these two angles, let's call it beta and beta right here. We know that they are congruent. All right. With that, we have two angles, really, we can see within kind of two big triangles here. The third one, we'll see, is kind of congruent with itself right here. We can see that, so I'll put a little mark there to show that, and it's equal. And now we can see that we have actually two similar triangles. Triangle CEF is similar to the large triangle CAB. Well, how does that help us? Well, similar triangles, their side lengths are gonna be proportional. And we actually have some information about that that may help us here, okay? Or the dimensions are gonna be proportional, okay? Well, the square here, square EFGH, let's go label each one of the side lengths as X, 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 and an X here, okay? So we know that the base of this triangle, EF, has a length of X here, okay? The height difference, well, if this whole thing from D to C is a 2, this little length here, I'm making a point, E, F, G, H, do I have an H or H, I, J, let's call it Z. Z to C is a length of 2 minus that height here, which is an X. So 2 minus the X is that length here, okay? And we actually have enough information, I believe now, with similar triangles to make a proportion, okay? So proportion here, we can say that AB, that length, AB, over the length of EF is equal to the proportion, the large DC, the height here, DC, over the height of the smaller triangle, which is CZ. Oops, not CE, CZ. Make it easy, CZ. All right, or sneezy, or sleazy. So let's go fill in the values that we know here and see if we can get some information here. So AB we knew as a length of 3. They told us that from the beginning. So we have 3 here over EF, which is an X, that length here. DC, okay, the large triangle has a height of 2 over CZ, where's CZ? CZ right here, that height is a 2 minus an X. And look, this is great. We have an equation here, equation that has X in it, and it's the only variable. So if we cross multiply up here, we're left with a 3 times a 2 minus an X is equal to, well, 2X. Multiply the 3 across, and we have right there, 6 minus a 3x is equal to 2x. Add 3x to both sides, 6 equals a 5x. And so I'll put it up here, divide both sides by 5. And we have x is equal to a 6/5. So if x is equal to a 6/5, well, that's the side length of our square. To find the area of that square is just a 6/5 side length squared, or side length times itself, 6/5 again. And that comes out to be, did I raise the decimal fraction? I did. 36/25 units squared, right there. Or as a improper or proper fraction, we have 1 and 11/25 units squared. Or as a decimal, because if we want all the different options here, is a 1.44 units squared. Either way, we got our area of our inner square, which isn't too bad to find, which was 36/25 units squared. Was that the answer that you got? If it was, great, way to go. If you solved this a different way, please let me know down in the comment section below. Hope you liked this video, and please like this video and subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.